Hi everyone, Tina here, and today I'd like to talk about some applications of differentiation that you'll usually come across during year 1 of your A-level course. I've made another video on the basics of differentiation, so I'd recommend you watch that one first if you haven't already. Let's go straight into some examples. Example 1, and this application is finding a tangent. So we've got y equals 2x cubed plus 5x squared minus 7x plus 10. Find the equation of the tangent at the point where x equals 1. Give your answer in the form y equals mx plus c. I'm just going to start by rewriting the equation, and then I'm going to think about what that looks like roughly. So it's some sort of positive cubic graph, so something like this. Now they want the equation of the tangent, and a tangent at any point on the curve is just a straight line that has the same gradient as the curve at that point. It touches the curve once, it might look something like that at that point. So tangent there. If I was to draw a tangent at a different point, maybe here, then it would look different, maybe something like that. Now, because the gradient of the tangent is the same as the gradient of the curve at that point, all we need to do is differentiate the curve equation. So if we do dy dx, that would be 6x squared plus 10x minus 7. And then we're going to find the gradient when x is equal to 1 specifically. So when x equals 1, let's find out what dy dx is. Sub that into your calculator and you get 9. This is the gradient of the curve and the tangent at that point. Now we know the gradient at that point, we also want to know the y coordinate. So when x equals 1, if we sub that into the original curve equation, we'll get this, and that gives us 10. So therefore, we now know that the coordinates of the point in question are 1 and 10. And now we have enough information to work out the equation of the line. So at this point, you can use y equals mx plus c, or some people might prefer to use the y minus y1 equals m brackets x minus x1 formula. It's up to you. I'm going to use y equals mx plus c. So 10 equals 9 times 1 plus c. I'll just show you where all of that's coming from. So the y was 10 because we worked that out here. Gradient m was 9 and x equals 1 in the question. So now we can solve for c, and c ends up being 1. Therefore, the final equation of the tangent, y equals 9x plus 1. Example 2, and this example is about finding the normal. So we've got an equation for y, and then find the equation of the normal at the point when x equals negative 2. Give your answer in the form ax plus by plus c equals 0, where a, b, and c are integers. So let's think about what a normal is first. So let's say for argument's sake, you had another cubic like this. And if I sketch on a tangent, as we discussed in the previous example, that would be a line that just touches the curve and has the same gradient as the curve at that point. A normal is also a straight line, but it's one that is perpendicular to the tangent at that point. So it might look something like that. So it's all about gradients again, means we need to do dy dx to find the gradient. But first things first, this y equation is not in a very nice form to differentiate. So I'd expand the top, and after you expand brackets and simplify, you get this. And then I would split that into 3 separate terms like this. Reason being, we can now simplify each of those terms separately. So here we could cancel an x from the top and the bottom. Same thing here, and we could cancel a 2 there. All in all, that is the same as 2x plus 7 over 2 minus x to the power of minus 1, if you rewrite that fraction part in terms of negative powers instead. That's way easier to differentiate. So now we can do dy dx equals 2 plus x to the power of minus 2. Now we're interested in when x is negative 2 in this question. So let's find the gradient when x is negative 2 first. When x is negative 2, dy dx is equal to 2 plus negative 2 to the power of negative 2, works out to be 9 over 4. This is the gradient of the tangent. We've got to be really careful here because actually we want the gradient of the normal, which will be the negative reciprocal because it's perpendicular. So minus 4 over 9. And that is your negative reciprocal. Before we can find the full equation of the normal, we also need to know the y coordinate at that point. So let's work that out now. When x is negative 2, subbing into the y equation gives this, which equals 0, means the coordinates are minus 2, 0. Now we can find the equation of our straight line, again using whichever method you prefer. I'm going to use y equals mx plus c. I'm going to sub all of my values in, so 0 for y, m was minus 4 over 9, x was minus 2, and c is what we're trying to find. C works out to be negative 8 over 9. Going to put that all together now. So y equals minus 4 over 9x minus 8 over 9. That is technically the equation of the normal, but it's not in the right form that they want. They want it to be ax plus by plus c equals 0, where a, b, and c are integers. So in order to do that, we're actually going to times everything by 9 to get rid of those fractions. So when you do that, you get 9y equals negative 4x minus 8. You can then rearrange that, shuffle it around, so it becomes 4x plus 9y plus 8 equals 0 for the final answer. Example 3 is about increasing and decreasing functions. We've got y equals x cubed minus 4x squared minus 3x plus 9. Part A, find dy dx. So we're just going to do that normally. So dy dx in this case will be 3x squared minus 8x minus 3. Part B, find the range of values of x for which y is increasing. Before we answer that, I'm just going to draw a picture here. So again, let's imagine a cubic. Now, for a function to be increasing, all that means is where its gradient is positive. So in this picture, those green parts would be where it's increasing. And that's when the gradient, or dy dx, is positive, greater than 0. On the other hand then, a function is said to be decreasing when its gradient is negative. And that's the idea. So to apply that idea to this question, we just want to know, where is dy dx greater than 0? So let's sub our expression for dy dx into there, make it greater than 0. This is now just a quadratic inequality problem. So solve it however you like. You get x is negative 1/3 or 3. Then always sketching a diagram for quadratic inequalities. Minus 1/3, 3, positive quadratic. We're looking for where the curve is greater than 0, means we're looking above the x-axis there. So our final answer is going to be two separate inequalities. One is x has got to be less than negative 1/3, or x has got to be greater than 3, and that's it. Last example, and this one's about stationary points. It says a curve has the equation y equals 4x cubed plus 15x squared minus 18x plus 5. Find the coordinates of the stationary points and determine the nature of each stationary point. So before we do this example, let's go through what stationary points are. They can look like this. So this could be a stationary point, this could be a stationary point, or these could be stationary points. This one here is called a maximum, this one's called a minimum, and these ones would be called a point of inflection. The thing they all have in common is that at stationary point, dy dx is equal to 0. The gradient is equal to 0. So at all of these points, the tangents would be a completely flat line going across. So to find the coordinates of a stationary point, you just need to differentiate and set the derivative equal to 0. However, to determine what type of stationary point it is, you need to consider what we call the second derivative, or second order derivative, and that's d squared y over dx squared, or f dash dash x, depending on how you've been using notation for the derivative in the question. For a maximum point, the second derivative would actually be less than 0 at that point. And that's because the second derivative is talking about the rate of change of the gradient. And at a maximum point, the gradient is going from being positive before the maximum point to being negative after. So overall, the gradient is actually decreasing. At a minimum point, we have the opposite thing happening. So the second derivative is actually going to be greater than 0. Or positive, because either side of that stationary point, the gradient is going from negative to positive. So the gradient is increasing. Now, for a point of inflection, the second derivative will be equal to 0, but you need to investigate the gradient on either side. And this is because for it to be a point of inflection, you need to show that the gradient is either positive on either side or negative on either side. So with a point of inflection, the gradient doesn't change from being positive or negative. It's the same on either side. So let's try and apply these ideas to this particular question now. Y is 4x cubed plus 15x squared minus 18x plus 5. So if we differentiate first, that's going to be 12x squared plus 30x minus 18. Now to find the stationary points, we set that equal to 0 and we solve for x. When you do that, you get x to be a half or x to be negative 3. Find the y coordinates at those points. You just sub your x into the original y equation. So when x is a half, y is going to be a quarter. And when x is -3, y is going to be 86. And I got that from just substituting into the original y equation up there. Now, to determine the nature of each of those points, we need to do our second derivative, so d squared y over dx squared. And you get this from just differentiating again. So if we differentiate dy dx, we get 24x plus 30. So again, this comes from differentiating this. You then substitute your x values in. So when x equals a half, the second derivative is 24 times a half plus 30, which equals 42, and that's greater than 0. That means that the stationary point a half a quarter is a minimum, because we said that if the second order derivative is greater than 0, it's a minimum. For the other one, when x equals -3, subbing that into our second derivative gives us -42 less than 0, means the point -3, 86 is actually a maximum. Second derivative less than 0, maximum, as we said up here. That's it for now. If you found this video useful, please do remember to like, comment, and subscribe to my channel if you haven't already. And do share this with anyone else you think might find it helpful. Thanks, and see you next time.